everybody. I'm going to talk to you about reproducible studies with Docker. Just get my copy here. Okay, so we're going to start with a little motivation, and then I'm going to explain what Docker is, because I don't assume that everybody has worked with it before, and then I'm going to introduce you to a new package we're currently developing called Containerit. A quick plug for my boss, who's looking for a postdoc with a great position in Münster, Germany, which is a beautiful city. So check that out if you work with spatial data. Okay, so I assume that most people in this room actually understand why we want to work in a reproducible way. But I like this paper, and there's probably 20 more papers out there giving you good reasons why you should work reproducibly. Maybe just to refresh our minds, 5 selfish reasons to work reproducibly is that it helps you avoid disaster. It makes it easier actually to write afterwards the paper about it. It helps you to convince people because they can look at what you really did. It enables continuity of your work. So you could of course say that future you could be your best collaborator if you work in a reproducible way, and by all of that also builds up your reputation. And on top of that, it's also just the right thing to do. So the motivation for us is the idea of what we call the executable research compendium, which is a concept to package everything that you have for a scientific paper. That means all the data, all the code, documentation, which includes the scientific publication, and also something we call UI bindings, which allows you to interact, look into such a package and change a parameter and see how the analysis would run with your changed parameters, to package all that in a way that is archivable. So we work together with people from the University Library of Münster who have their minds on metadata and preservation. And one very important thing is that software for us does not only include the script that you wrote or the R Markdown document that you wrote, but also the runtime environment that was used to create an analysis. So how we imagine such an ESC is created, we don't expect that everybody would like to do that himself, but we think that we want to integrate this into the current publication platform. So where do you publish? You go to a publisher, you upload your data, and on this publication platform we try to reduce your work because nobody wants to write metadata, it's not fun. So we try to extract as much as we can from the documents in your upload. Then we execute the analysis. We do that for 2 reasons. One is to check if what you uploaded to us is actually the same than if we rerun your analysis. And the most important part here is that this allows us to capture the runtime environment, so all the packages that were used, etc., in R. And here we create 2 things. One is a manifest, so like a recipe for the environment that can reproduce your analysis. And the second thing is the image, so an executable binary, basically, with all the information or all the libraries, all the system libraries that you might not even be aware of, all packaged together. And then the user in the end has to check if the metadata is all correct, because that's something that we cannot do. We operate basically on a syntax level, and then we can publish that in a sensible way, for example, on Zenodo. So, who has worked with Docker before? Very good. Not all hands up. So I'll make a very, very brief introduction to Docker. One quote from the founder of Docker, Solomon Hykes, is that the real value of Docker is not technology, it's getting people to agree on something. So containers were around before Docker, but they were really the first ones to make them work easily for people. So why it sometimes might feel like everybody uses Docker and you're just sort of dragged and forced into that, and you're not even sure what it means. Hopefully after this presentation you also like to try it out and not just do it because you're forced to do it. So when I look at the Docker overview on the Docker website, what do I read here? I don't read anything about science. I don't read anything about data science or reproducibility, replicability. That's something that they don't care about. What they care about is packaging an application and all its dependencies in a separatable way so that applications don't interact with each other in a way that they shouldn't. And with all their dependencies, put them into the cloud. So the typical use case for Docker is you work in a big data center, you realize that there's a few thousand people wanting to write an email in Japan, and with a few commands you can spin up a couple of hundred or thousand new machines to serve that demand. So that's nothing that we do really when we do data science, but we can still profit from the stability and all the features that Docker provides us because of all the big use cases and big companies behind it. So one way to look at it, and maybe to understand the concept, is that most people have heard about what a virtual machine is, right? It's like a virtual computer. And a typical comparison is that a virtual machine is like a house. It's all yours. It stands on somebody else's ground maybe, but it's still all your house. Whereas a container is more like an apartment. You share some infrastructure with other apartments, but when you're in your apartment, you can do what you want in certain limitations. So Docker basics is what you normally start with when you want to create such a Docker container is a Docker file. This basically has instructions on how to create the environment. You're not doing that. You can also do that interactively by hand, but the same thing that applies for reproducible research is if you do something by hand, how will you know in 2 or 10 years what you've done? So the Docker file is like a recipe. You can use the Docker command line to build this recipe into a Docker image, and then this image can be, when you run it, it becomes a container, and this container can be paused, it can be stopped, it can be restarted. You can copy files out of the container, you can execute it, you can do many different things with it. So if you stop it, it actually doesn't disappear, you can restart it. But you don't have to do this yourself. You can also rely on other people's images. So there's a huge image registry called Docker Hub, and I can just run Docker images from there as well. Okay, so Docker file is built into a Docker image, and if I run it, I have a container. Now you know everything you need to know about Docker. How is it important for data science? I basically already touched all these points. It can be used for reproducibility. You can also separate your projects. If you have different clients, you just start using one container for each client, and then you're always sure to be in the same environment that you left before. If you want to try out a new package and you're not sure about it, or if you want to try out a 2-year-old R version with your current package and you don't want to install that into your actual machine, you can do all these things in a container. And because development or DevOps operations people, they know what Docker is, it's also very easy to transition from something that you do on your own machine and get it on an actual production server. If you are interested just in getting to know Docker, there's great Docker tutorials around. I've started a Docker tutorial that is focusing in the language and ideas on reproducible research. It's online on GitHub and uses the author carpentry template. So if you want to take a look at that and give me some feedback, that would be great help. So I'm not the first one to use R and Docker together. There's actually the Rocker project who's providing all the base images. So if you create an image and you can just run Rocker images, such as different R versions or even RStudio, they do all that already for us, and we are reusing that. Just as an example, at the bottom, this Docker run command, the second to last line, that's everything you need to run on your local machine once you have Docker installed to run an RStudio server. And you can go into the browser and use it. And there's also Bioconductor who has a lot of images ready to use for you. So let's take a deep breath. For everybody at least who this is new for, and dive into what we've now created. The package is called Containerit, and it basically is a tool to generate Docker files from our environments. So if you remember the creation process of this executable research compendium, you upload your workspace, And then we need to do some magic. We need to recreate then an environment that is as close to yours as possible. It's on GitHub, and it's currently in a beta stage. There's also a blog post that is sort of a draft for a vignette that we're currently developing. So how does container work? Let's say we want to package an interactive session. So we start loading some packages, of course also container it. We're loading some data. We are doing some analysis. We're creating a plot, just like you do. And then we call the Dockerfile function, and which creates a Dockerfile object. And this object, we can just also has, when the Dockerfile function runs, there's also a few logging statements there, so that you know what's happening. So when we look at this Dockerfile object and we print it, we actually get a Dockerfile. So this Dockerfile has a few different statements. The first one is from, so it's the base image. You can see here that we use the Rocker image and our version 3.4.1, which is the version that I'm currently running on my machine. We have a label, which is automatically created from my username, saying that I'm the creator of this Dockerfile. And then we have a run command, which creates creates a command that when the Docker container is built, is executed. And here we use the install to R, little r script to create, to install our packages. And at the end, we have the same command that's already in the Rocker version. The command is simply R. So when you run the container, you'll actually get an R command line. And the structure of the Dockerfile object is it's an S4 class with all these instructions and information in there. So we can also manipulate that step after step. So packaging interactive session, but of course also you have sometimes just an R script that's ready to use. You've already have that, and how can you package that? I think it's even this. Now it's a slightly different script. So we're using the library GDAL here. Read a file and do a plot and also a summary function. So here we have to change the command of the main command of the Dockerfile. So in the end, in the other Dockerfile was just run R, but in this case, when we package the script, we just want the script to run when the Dockerfile is executed. So when you build the image and you start the image, it will actually start the container and immediately run the R script. So this Dockerfile object we create with two commands. One is that we tell them what the file is, and we also tell them this command. What's happening now is, and also happening in the other case, but I want to point it out here, that we use the sysrex package, which has an online database of mapping R packages to their system dependencies. And we use that, so here in this case, to create this Dockerfile, which as you can see here in the middle, we are actually installing system packages. And this is where we hopefully can take off work from you, because you don't have to remember you don't have to remember what all the system dependencies packages are. So when you run this now, you can write this Dockerfile object into a file. You have to, right now, I use the example going to a regular command line. I build this Dockerfile into an image that runs for a few minutes, maybe even with a lot of output. But you see that all the packages are installed, all the system dependencies are installed. And then when you run it, you basically get the output that R is started and the script is executed. Okay, there's also a CLI version that we're currently developing. It's not as stable yet, but you could just use it from your command line to package an R script in the same way. So I'm going to jump through that. There's more to the package. We can also create labels, for example, to use metadata. We can also build up on a dev tool session information. We're currently experimenting with installing packages from GitHub as well. And you can, of course, also provide your custom base image if you think you want to use something else than the Rocker images. So there's this blog post if you're interested in everything that happens around Docker and R. There's also a great paper by Karl Böttiger who really inspired all this work, introducing Docker for reproducible research. So quick summary. Executable research compendia are fun because for us they're a way to learn and find out how we can create executable research and reproducible research. Docker is great. Container, it makes life easier for you because you don't have to repeat yourself. You don't have to repeat or copy and paste from one Docker file to the other. You can rely on automatic generation here for things that we don't really want to do by hand. We benefit a lot from Rocker and also other packages that are around, for example, Harbor, which actually lets you, the Docker run and Docker build commands, lets you do those in plain R. So give that a try. And of course, there's many alternatives to do this, to do reproducible research. A few I mentioned there, like Packrat, Checkpoint. You can even use or switch R and Grambase. But we see this more as a complementary approaches to what we want to achieve. Okay, so a quick outlook. We first of all have to support our own project, of course, but we would really like to get your feedback on this. And since the package is called Containerit and not Docker, we already have in mind to play around with other container solutions besides Docker, and see what we can do with more features. So everything is on GitHub. If you're interested, you're welcome to collaborate. And I hope that you're going home now and thinking, yeah, this Docker thing, maybe it's something that I want to try out. So thank you.
So we do have a few moments for questions officially, and I'm aware that people might want to run for lunch, but if you can contain your enthusiasm until we can hear the questions, please.
Yes?
That was very impressive. I sort of glanced at a few things that sort of picked up stuff that I've done in coding,
Okay.
install out and live and all the rest of it. What you didn't say though was that you can only ERC a Linux session, right? That assumes that sort of you can't offer that to a Mac user or Windows user, is that correct?
Well, the Docker file generation is just a regular R package. So that runs everywhere.
Well,
And
install 2.R doesn't because it's littler, and already on a Mac we have this problem that in Cupertino they think that lowercase I and uppercase I is the same. It's not. And so
okay, no. So in the
in the
yeah.
Linux world, and this will work for me today, and this is fabulous. You have the point of singularity and all the rest of it, but you may need to sort of stress that you can bundle up things, provided that you happen to work on the operating system that you should be working on sites in the first place.
Well, so in the container, we are currently limited to the Linux operating systems, but Microsoft is pushing hard. I would expect that.
Other things that you did really, really well. For example, leveraging Gabo's database for the system requirements, which is sort of cross-platform, but not quite.
Yeah.
We're trying to get in there by getting more brand packages, possibly all as dead binaries, so that they
So that.
install and stuff like that.
Right. So that would be something.
I was waiting for you to bring up GDAL because that's the single biggest headache for everybody.
Yeah.
You stand as a prime example. If you master that, then you master a lot of pitfalls. So that's really good.
So there's two things that we, of course, want to take the workload of people as. One is if you, for example, have not a Debian, but maybe a Red Hat base image, then we would like to switch the installation commands for you. There might be different package names. And if you use something like GDAL, we also have these switches that in some cases we even insert the installation from source commands into the Docker file, and that's something that not everybody knows right away. Yeah.
Sounds like you guys have got some more to talk over lunch.
Okay, thanks. I'm
Can
going
I
to take
thank-
that question in private and let everybody go for lunch?
Yeah.
Okay.
So if we can thank all the speakers, please.